Yeah, that's about it. Thanks, Shane. So today I'm going to be talking about firewalls. Cool. So what is a firewall? Actually, one sec. I'm going to make sure this didn't break yet. Hey, nothing broke. OK, cool. Stuff's working. So what is a firewall? That's a firewall, but not the type we're going to be talking about today. Same thing with that one. And that one, might not have known that that's called a firewall. To keep fire from spreading through a house. But no, today we're going to be talking about firewalls in the computing sense, where a firewall is something that keeps the bad guys out. It controls what traffic is allowed to flow into and out of a computer or a network, and keeps the bad guys from being able to see everything. So how do computers talk? Computers use IP addresses and ports to talk. If you haven't taken networking already, that might blow your mind. If you have taken networking already, you're probably like, oh my god, stop talking. Computers send data in little packages called packets, which is just small amounts of data that have some information attached, like the IP address and port of where it's going. So I'm going to give a really brief overview of that for anyone who doesn't understand that already. So IP addresses, you probably know what these are already, especially if you're here at DSU. But there's two different main types of IP addresses, IPv4, IPv6. IPv4 is 4 numbers that are 0 to 255. IPv6 is a lot of hex digits. We'll only be using IPv4 today because IPv4 is a lot nicer to look at and type. The IP address is just a label of a computer on a network. Yeah, that's about it. So what's a port? A port is like a window into a computer. It's how you talk to a service that's running on a computer. So there's two main protocols that use ports. That's TCP and UDP. So TCP is a connection-oriented protocol, which means that there's a handshake involved. You form a connection. It's gently placing the data where you want it to be, making sure it gets there. There's error checking and correction. And that's generally used when all the data is important. You don't want your website to show up and it be missing a few lines of HTML in the middle or something like that. UDP is connectionless, much faster, used when data loss is OK or tolerable, and speed is much more important. As things are getting better and better, we can use UDP more because data loss doesn't happen as much. But data loss still happens. So the other important thing is that UDP, your traffic might not arrive all in the same order. There's algorithms to fix that, but important things. Some other networking terms. Network, I hope you know what that is. Group of computers that talk to each other. Subnet, smaller group of computers. LAN, WAN, different types of networks. Most of that, not particularly important, but it's important, but not so much for this. Fun fact, DSU owns 138.247/16, so that's 65,000 IP addresses. Yeah, that's kind of cool. Subnets, subnetting is pretty complex, and if you have no clue what that is, then congratulations, networking will be fun for you. But some important numbers, so slant 24 subnet means that the last octet in the IP address can vary from 1 to 254 to address all hosts on the network. So there's about 254 hosts on the network, or max. Slant 16 is the last 2 octets, and slant 8 is the last 3 octets. So what's a firewall? Firewall controls inbound and outbound traffic. It allows and blocks according to a rule list it has, and helps to keep the bad out. Firewalls are pretty important, and when misconfigured, they can be pretty bad. So this is a screenshot from CCDC, what was that, regionals last year? I don't know, whatever we did, CCDC last year. So I don't know if any of you have seen a scoreboard like this before. The green means your services are online and up, good. Red is down, bad, not good, can't connect to your services. And I don't know if you can tell when I restarted the firewall, but yeah. So that's what it looks like when you mess up the firewall. Or this. It also looks like this sometimes. We try to avoid that a lot. Yeah, so we try to avoid all red. Thank you, Shane, for your astute question. Red means down. Red is bad. Don't get red. Red means that you can't connect to the service. So if your firewalls are up a little bit too strong, can't connect. That's not good. So different types of firewalls. A few different firewall words, host-based, network-based, stateful, stateless, layer 3, layer 7, ingress, egress. I'll go over these in just a moment. But first, a meme. Bad meme. OK. And literal walls of fire, but we won't be going over that today. So host-based versus network-based firewalls. Host-based firewalls are on one computer, one host. That's like Windows Defender, iptables, or Apple garbage app something or another. I think it's called application firewall. I don't know. Yeah, so that stops traffic going into or out from one host. So that's just one computer. Network-based firewalls is a separate dedicated application on the network. So that's your router probably at home, well, hopefully. Or for DSU, in the server room, there's a bunch of routers that have firewalls on them and a bunch of just dedicated firewalls. So a network-based firewall helps with segmenting different parts of the network, separating traffic from going from one group of things to another group of things. People in the dorms probably shouldn't be able to talk over the network to people in Mad Labs, stuff like that. Separating the network, keeping stuff contained in that sense. And you can also use network-based firewalls to control traffic going to and from one box, but it's generally better to have host-based firewall rules and network-based firewall rules, not just one of them. So stateful versus stateless. Stateless firewall rules don't track connections, so that means every packet that I talked about earlier is filtered based only on the information it contains. So when it gets a packet, it looks at the IP address, looks at the protocol, looks at the port, and then makes a decision. In order to form a connection, like to get a website, you would need two rules for that connection. One for the HTTP request going out and one for the response coming back in. Stateful firewall, on the other hand, tracks the connections in a state table. So it can allow connected and related traffic to a connection. So then you'd only need one rule. So for example, if you add a rule for HTTP out, then when you send a request out and the server's replying, the firewall would see that, recognize that it's from a previous connection that was allowed, and allow it through. So generally, stateful is better, but there are some times when you might want to use stateless if you want to inspect every packet. Speaking of inspecting packets, layer 3 versus layer 7. So layer 3 firewalls are ones that check IP address, port, protocol. That's about as in-depth as they get. Maybe a little bit more, but probably not. So that's allow port 22 TCP, that's SSH, or deny port 53 UDP, something like that. So it allows one port, or maybe it allows a destination or source IP address. Pretty rudimentary, but a very good first step in firewalls. If you don't have a firewall and then you have a layer 3 firewall, that's much better than not having a firewall. Layer 7 firewalls, or next generation firewalls, whatever, fancy terms, that actually does packet inspection to figure out what the actual traffic is. So it might be port 22 TCP, but is it actually SSH traffic? Is it HTTP traffic instead? A common way that red team can get out of a network is by going over a port like port 443, which is normally HTTPS. But if you have SSH going over that port, it's also encrypted traffic. So it doesn't look the same at the network level, but from a layer 3 firewall, it sees, oh, hey, there's traffic going over port 443. Guess I should allow that through since I'm allowing HTTPS. The layer 7 firewall would be like, hey, that traffic is SSH and not HTTPS, so we should block it. Or, I mean, if you want to allow that. It also means you can do cool things like allow a certain protocol on every port. So you could be like, allow FTP on any port. Or a more sensible option of blocking FTP on any port. Ingress and egress. Ingress and egress work together. So ingress is incoming traffic, egress is outgoing traffic. You want good firewall rules for both. A lot of times people will only focus on ingress firewall rules and not so much on egress firewall rules. And as a result, it's really hard to get into your network. But once someone's in your network, they can just beacon out, and there's not really a lot of restrictions. Generally, like with home routers, there's a lot well, everything's blocked off coming in, but not really anything's blocked off going out, except for like port 25, I think, or something like that. Yeah, so ingress versus egress, good to have both of them. In CCDC, if red team gets onto your box somehow through like some buggy web app, and you don't have egress rules, then red team can just set up a listener and get callbacks. Fun stuff. So some terms to know. Allow or accept, that lets a connection go through. Deny or drop silently blocks the connection, versus reject, which sends a message back that the connection was blocked. So the important distinction there is if someone's trying to talk to you, well, a computer's trying to talk to your computer, and you deny the connection or drop it, the terms are different based on the software you're using. You drop the connection, then you don't tell them that they can't reach that port, which means that when they're being like, hey, send me your website, hey, send me your website, and you just don't reply, ghost them. Versus rejecting, where you're like, hey, that's not a thing, I'm not sending you that, you're not allowed to talk to my website. Security by obscurity is not a good thing. However, there is some sense to dropping things as opposed to rejecting them, like particularly from the WAN. If someone's scanning you and they have to like ping every port a lot of times to see if it's open, because their packets might be getting dropped, that takes a lot more time from them than getting a nice little rejection of like, nope, not right now. Also saves you some processing power if you just like discard the packet, don't think about it, versus having to craft a response and send it back. So a default or policy, depending on firewall you're using, is what happens if traffic does not match a rule. So you can add rules to your firewall, which I'll go over in just a moment. And if something doesn't match, then what happens to it? Does it get dropped? Does it get accepted? Kind of important to make sure that that's dropped generally. Otherwise, if you don't have a rule for a specific case, then the traffic's just allowed, and there's not a ton of point in having a firewall. So what is iptables? iptables is firewall application for Linux. It has lists of rules or chains, checks the rules from top to bottom, and the first match wins. So there's three main chains: input, output, and forward. We won't really be talking about forward today. Input and output, hopefully pretty obvious. That's what's coming into your computer and what's going out of your computer. So the input is your ingress and the output is your egress. So when your computer receives a packet, and after it's like been decoded by your network drivers, it goes into your input chain, gets processed through any rules there, and then if it is applicable to the local machine, it'll go to some process locally or something like that. And then the local process, if it wants to send a response, so say you're running a web server and you just got in a request for the front page, then it will send the output to the output chain, where then it gets processed, and if it's accepted through that, it gets sent out. Hopefully, that's pretty obvious. Probably went too much into depth on that one. So, iptables. This is where it gets fun. This might look kind of complicated, and that's because it is. So there's a few basic commands to insert a rule at the top of the chain, append a rule to the bottom of the chain, or delete a rule from the chain. That's like your basic, flags. So this is basically what you're doing with a chain. So from these three chains, your input, output, or forward chains. Can you see that? You can't see that. Can I get a, aha, laser pointer? Yes. So if you wanted to like add a rule to your input chain, then it would be iptables tac I to put it at the top, or tac A to put it at the bottom, name of your chain, which would be input, and then the options. So this is where you specify what rule you're doing. So there's different flags for the different rules you're doing. So like tac S would be to specify the source, tac D would be to specify the destination, tac P for the protocol, and so on. I'm going to take a quick moment to make sure that the VApp is actually running for me, so I can give you a demo, and not a demo on my host. This is very interesting. Also, if you filled out attendance today, then hopefully you got a VApp. If you didn't get a VApp, that is sad, and it means my script probably didn't work right. Yeah. So it looks like I got, almost everyone has VApps so far. if you still want to VApp, go ahead and fill out attendance. Yeah, hopefully it should work. If you didn't put in a valid username, it just would not deploy something to you. Looks like the last batch completed successfully, so I just sent another batch, and hopefully those will be coming in soon. Maybe? Looks like my script is working. Look at that. My info works, after all. This is fun. Lots of VApps. iLab is very happy right now because I'm pushing a large amount of VMs. In case you didn't know, the default password is going to be password1bang, as always, with every DSU VM ever, except for the PF sense. Okay, so these rules, talked about these already a little bit. So let's get a demo of that. So if we look at that, my script worked. So everyone that got a VApp should be on the same network, which is 10.20.1.a number. That number is your number, smiley face. So theoretically, you can hit each other's VApps, which means that you can hack each other. Don't do that yet. Wait till people start putting up firewall rules. But you can put up firewall rules and try to not get hacked. Good luck. So first of all, you have to be sudo to do this. Doesn't really make sense to be able to change your firewall rules and not be sudo. All right, so first of all, can everyone see that? That is not easy to see. Still can't see it? What about now? More? More? That's good? That's good? Okay. Everyone can see this? Look at that, fancy prompt, so you can actually see what I'm typing. Password 1 exclamation point, capital P. What? You don't have to. I mean, you don't have to follow along, but if you want to. Oh, yeah. Well, of course, then you can test it that way. So iptables. So the base command, iptables. If you're on that, it'll yell at you. So let's say we wanted to add a rule to like the input chain. So let's add a rule to input. And let's say that we want to allow, I don't know, maybe SSH in. So we're going to say protocol, which is TCP, and then the destination port, which is 22. So in case you didn't know, SSH, TCP 22, probably a good thing to remember. And we're going to say that what we want to do with that is allow it. So that's going to be tacj accept. And look at that. Nothing happened. Didn't yell at you. That means it probably worked. If we wanted to test that, we could do iptables tacl. And I don't really like this interface. I find this a little bit hard to see. There we go. So you can see this. It says TCP from anywhere to anywhere. It knows that this is SSH. The SSH port doesn't necessarily know that it's SSH traffic. I find this interface hard to use, so I generally do iptables -save, which just dumps out a script of the configuration. I find this a lot easier to look at because then you can see like the entire command instead of like just part of it. So yeah, theoretically, now if someone tries to SSH into my box, they can do that. Give me just a moment. All right, so, whoop, no, didn't want to do that again. Okay. So yeah, this is saying input rule allow TCP22. One important thing is that the default is currently accept. So that rule doesn't really do anything. I mean, it does allow the traffic, but the traffic would be allowed anyways. So let's fix that. So let's say iptables. So we're going to change the policy, which, oh, I don't have that slide up yet. OK, so next slide, policies, important. So TAC-P is how you change the default policy for a rule. So we're going to do iptables, TAC-P, and then what? Too small? Is that better, Shane? Can you see the slides now? OK. So TAC-P is the default policy. So this only accepts 2 arguments, a chain and what to do with it. And this is actually incorrect. You can't reject stuff on the default policy. Yeah, they want you to use drop instead, which makes sense. So let's say that default policy for input is going to be drop. So now, iptables -save, you can see this changed input to drop. So now what that means is that if you try to connect to this computer, you should only be able to connect to it on TCP22, because I have a rule to allow TCP22, but then there's this rule, the default is drop. So anything that doesn't match that one rule now gets dropped. So if anyone wants to test that, go ahead and try to connect. Anyone? Anyone want to confirm this from their box, that they can SSH into my box? What is it, 19160? Oh boy, that is legible. Can anyone SSH into this IP address from their box? Anyone? No one? OK, cool. Look at that. One person can. Awesome. So that means SSH works. So let's try some other stuff. So let's say that you wanted to allow outbound traffic, like most outbound traffic, but maybe you didn't want to allow a certain port. So you really didn't want people to do HTTP outbound. Sounds like a great idea. Don't see any possible problems with this, other than me forgetting in a few moments that I blocked this. So we're going to append to the output table outputs. So protocol TCP destination port 80. Excuse me. And what we want to do with that is drop it. So now, theoretically, if I try to curl something, it just doesn't work. Look at that. Doesn't work. Super cool. Let's say that was a mistake, because now we can't access the internet, and we want to fix that. So there's a few ways to do that. One of the ways is to just delete everything. So that can be done with iptables TACF. You could delete the individual rule, but I'm just going to delete everything. So now if we look at iptables-save, you can see there's nothing. But importantly, the default policy was kept. So input is still drop, which means that all traffic coming in is still getting dropped. But now, theoretically, that's awkward. Let's try this with something else, where we almost definitely can access it. Maybe? Why is networking broken? Shane? All right, that's fun. Networking's broken in general. What's up? Interesting. Oh, right. Haha, I know why. Remember how I said I'd totally forget later? Yeah, look at that. So this input rule is drop, which means that we're sending responses out. And we're like, hey, website, come talk to me. Hey, website, do you exist? And the website's like, yes, I do exist. And then the computer just doesn't listen to the response. Super fun. So let's fix that. iptables, TACP. What? How many people do I have? Like 20-something. Last one I deployed was number 25. Nope, 27. So we're going to change that default policy back to accept, which means that now, hopefully, hey, look at that. Now I can ping stuff. Awesome. So if we want to like curl, look at that. Now we can curl stuff. So now if I add back on to that drop rule for port 80 outbound, and I try to curl something, there we go. Now it doesn't work. Look at that. Now my demo's fixed. Cool. Any questions so far? Really active audience tonight. All right. What's my password? Password one bang, capital P, exclamation point. Already tried that? Well, it doesn't work. Wonder why. Oh yeah, so if you didn't get the VM, you can do attendance, and hopefully you'll get the VM. That's very hopeful, hopefully. Otherwise, you can pull it yourself from the catalog if you know how to do that. Oh, it looks like some people may have not actually gotten this. Give me a sec. My script works perfectly fine, Shane. I just need to get the data in the right format. Thank you. I appreciate that. Maybe? Thank you. Thank you. Shane, looks like the new number is going to be 27? How's 37? 38? 39? 39. How's 39? Some of those are duplicates. I don't know which ones. There's 39. Wow, that's actually a lot of people. I deployed 39 VApps. All right, so anyone still not have the VApp or a VApp pending for them? You should have it. All right, cool. On my box? Yes. Any questions? All right, so if you don't want to get hacked, you should probably put up some iptables rules, because all the boxes have the same default password and a few other goodies if you're red team and want to experiment with getting into other people's boxes. So maybe you should throw this one up there. iptables tacp input drop. That will throw away all input traffic. However, let's see. Scoring engine up? Okay. Okay. Show him how to pull it from. Correct. Okay, so, oh boy, this displayed wonderfully. I don't see any problems with this. So if you're on a box and you want to, you can open the web browser. Need a Jeopardy music button. And go to 10.30.0.100 in the web browser. Maybe this will work. Oh yeah, I might need to adjust that. (10.30.0.100). Uh-oh. Yeah, that's working. Oh, nope, that's not working. There we go, 10.30.0.100. You'll get this nice, beautiful scoreboard. If you open up terminal and type IPA or type ifconfig, you'll get an IP address listed for you. So right here, I'm 1021.1. If you take this last number here and hop over to the scoring engine, you should see the last number next to like team and then the number. That's your box. So right now, some of your services are probably up and some of them are probably down. So the green arrows mean good, the red arrows mean bad. However, right now they don't necessarily, or good does not necessarily directly correlate to up. So theoretically, you probably don't want, Postgres, SQL, or Telnet online ever. So those ones, it'll be green if the service is down. The rest of them, it'll be green if the service is up. So you want to try to get all green. If you can get your row all green, then like, congratulations, you get a high five, a cookie. Sure, if you want a high five, I will give you a high five. That was all the motivation he needed. All right. So if you want to check how you're doing, you can check that scoreboard. Hopefully it's up to date and works. Yeah, VApps are deployed. Or, more or less. Is what? I could tell, it's fine. Okay, anyone else still not have the VApp other than these 4 people that I'm pushing to right now? One of them's you. All right, cool. So now everyone's VApp should be up in just a moment. All right, so let's set up kind of an example for like how you should set up this box. So if you run netstat, great command, shows you what's listening. Oh boy, that's an output right there. If you run netstat, it'll show you all of these wonderful services that are listening right now on your box. Some of these services are probably good ones that you would like to be listening on your box. Some of these probably not. But let's say you needed those services up still. Like, you can't really take down a database. I mean, you could fix the address so that it's not listening globally. Maybe you don't know how to do that. Or maybe it's a custom service and it has to listen that way for some reason. But 3306, that is MySQL for people who do not know that. MySQL is probably not something you want exposed to the internet. You might want this exposed to an internal network so that like a website can... Oh, interesting. Cool. Everyone's Postgres works correctly. Whoops. Yeah, so your database, you probably don't want that to be publicly accessible on the internet. So let's say that for whatever reason, whatever flaw of judgment, these host-based firewall rules are the firewall rules that are preventing traffic from the internet from getting to this box, or more accurately, traffic from red team from getting to this box. You're probably going to want to block port 3306. Don't really want red team to have access to your database. So in order to block that, iptables, we're going to, this time, we're going to insert onto the input chain. The port is port TCP. Destination port is 3306, and we want to drop that. So that means, theoretically, when red team tries to connect to your database, it's just not going to connect. That's good. Now maybe something like, I don't know, SSH. Maybe SSH is a scored service, or SSH is important somehow. Maybe that's how you're connecting to your box. You probably want SSH to be allowed in. So that's a little bit difficult to see. There we go. So we're going to allow SSH in. Can use the same command and just change this to port 22. Whoa, not 222, 22. And change this to accept. Now, port 22 should be allowed in. Port 3306 should not. Assuming you followed along with those two things, theoretically, your box is going to be green now. This is moment of truth for does everything integrate together. So SQL, that's this column. Oh boy, where is my box? I'm box 1. Oh yeah, right at the top. So SQL, awesome. So SQL is being blocked, which means that this went up. SSH is being allowed. Well, and everything else is being allowed except for Postgres, which is just green for almost everyone. But everything else is being allowed because I don't have any other rules restricting stuff. So if we went back to this VM and now fixed that default rule, so we're going to iptables, TACP for policy, inputs, drop. So now that's going to drop all the input traffic, as I already said. Hopefully, in the next few moments, some stuff's going to go red here. That might take a little bit. In the meantime, let's look at some other things you can do. Hopefully, everyone understands that like drop and allow by now. So other fun things. So you can change rules for specific interfaces. So say your computer had like 2 network interfaces. You could say, you know, I only want this to come in on this port from this interface. For example, for the router in IALab, the DefSec router, there's some rules that only allow, you know, the management interface to be accessed through, or the management website to be accessed through specific interfaces, so that you can't access it from all the interfaces. You can access it from most of them, just not all of them. Another common use for this is to allow local traffic. So now we have this nice drop rule as the default policy for our input. But now let's say we wanted to like connect to something locally. So we wanted to like curl our own website locally. That's not going to work anymore because it's blocking all traffic, even traffic that's going locally within the box. So in order to allow that, we can do iptables. We're going to insert into the input rule. So on the input interface local, so that's tac I space LO. So anything that's coming in on the local interface, we're going to allow that. And same thing, we're also going to do for output. So that's going to be tac capital I output, tac lowercase o this time, because that's the interface it's going out on, local, tac j accept. So now that should allow local traffic. So if you like curl localhost, oh, maybe. I didn't spell that right. There we go. Curl localhost. You can see my web app 1 final project. Hope you guys like it. Thank you. Yeah, so now all traffic locally is being allowed. This is important if you like have a database for your website or something like that. The website needs to talk to the database. If you're blocking all traffic inbound and outbound except for the website, then the website won't be able to access your database, even if it's local. So it's important to have local rules like this. Let's see, what other things can we do? Yeah, so right there I have that. So the next thing is stateful versus stateless. So currently, iptables is running in stateless mode, which means that for a connection, we need to have an allow rule for the connection going in and going out. So if we want to get a website, so if we want to get the scoring engine, we need rules that allow us to talk out to the scoring engine and rules that allow the scoring engine to talk back to us. So let's say that we only wanted to do one of these. We can actually put iptables into a stateful mode using this contract parameter. So I'm going to attempt to type this out without spelling it wrong. Probably going to spell something wrong here. So if we do iptables, we're going to insert into the input chain. So tac m is what module to use. We're going to use the contract module. So CT state is what connection state. So you can put new, related, or established. You probably don't need to do new. I mean, if you're allowing new connections, then you can just do it without contract. But this is for related and established. So let's do related. So related, established. No, that's probably wonderful to read, but yeah. And then we're going to allow that. So now, theoretically, even though input is being dropped, since we have this contract, which is that rule is stateful, so that looks at the state and sees if the connection was already allowed before, it accepts it. So now, theoretically, if we curl this, look at that. We can access the scoring engine. So we don't specifically have a rule that allows port 80 from the scoring engine to come back in. But because of this, and because it's already allowed outbound, then it's allowed back inbound. So that's pretty nice if you don't want to have to do like 2 sets of rules, or in the case of FTP, a lot more potentially if you have a bunch of different ports. You can also specify port ranges, but generally you won't need to do that. Let's do something else. So what if we want the output to default to deny? So let's say that we're getting later into the competition, and we got our input table or input rules set up decently, and we want to start blocking outbound connections that aren't specifically approved. So if we just set the policy on output to drop, now we're not going to be able to do anything. So like, we won't be able to access websites. None of the services on this box will work. So now we need to add some rules to allow us to access websites. So if we iptables, we're going to insert into output. What did we learn today? I'm bad at spelling. Port TCP destination port 80. Accept. Now, what about our servers? So our services. So if we wanted to allow people to connect to our SSH server, we're not allowing the SSH server to talk back to them. So that we're going to need a similar command, but we're actually going to change this a little bit. So it's S port. So that's going to be source port. So when 2 computers are talking, there's a source port and a destination port. The source port is where the whoever's reaching out to the server, that's a port on their machine. And the destination port is a port on the server. So the server needs to know how to reply back to you. So if you access a website, the website needs to know where to send that information that you just requested from it. So that's where the source port generally would come in handy. However, when the website's responding, or when, in this case, the SSH server is responding, the source port is going to be that server port. So when you talk to an SSH server, you're talking to the destination port 22, and when the SSH server is replying to you, it's going to be coming from the source port 22. Did that make sense? Any questions? Maybe? Okay, got 1 thumbs up. Awesome. And a thumbs down too. And say it balances out. So let's try to make this green. Oh yeah, currently everything's red. That's fun. So everything's red right now because I'm just dropping everything. In order for these ones to go green, we're going to need to reject the traffic and not drop it. So let's do that. So we want, let's see, so we want, well, that's already going to be dead. So we want SQL to be rejected. So iptables, going to insert into input. There we go. So for protocol TCP destination port 3306, we're going to reject that traffic. Now, hopefully, this little circle is going to go green soon-ish, maybe in a minute or 2. We also want to allow SSH, so We allow input, we allow output, SSH. I probably spelled something wrong there. Not sure what. Okay, something might be broken. That's always a fun game to play. What's broken? Oh, we can also make this stateful outbound as well. So this only allows stateful inbound. We probably also want that outbound. So we're going to add to the output that same jargon. Oh, I spelled output wrong. Output. It'll yell at you if you spell something wrong, sometimes, normally. Let's see if that fixes it. That'd be awkward if it didn't. Maybe? Well, maybe something else is broken. Potentially indicative of a bigger problem. Who knows? All right, let's just keep going and come back to that later. Yeah, so, here's some more examples. So we have that contracts for allowing already established connections. Oh yeah, right, so we can also do some fun things, so like source IP address. So say we only wanted a specific person or a specific source to be able to SSH into the box. So we can do something like iptables, a input, tac, TCP, tac, dport 22, tac S for source, and then put like, I don't know, maybe 10.31.0.2. Random IP address. Oh, I messed up something. And then we're going to say that that gets accepted. Oh, nice, that projector died again. This has been happening a lot lately. Cool, that projector doesn't like anything. This one still works. That's a good projector. Oh, you poor thing. Slides are... So yeah, since that projector died, and I didn't really have anything else, yeah, the lab. That's about it. Yeah, that's basically all I have. So any questions? No? Awesome. Still no questions. Anyone not have questions? You? Annabelle? Good question. Probably because I denied something. Oh, look at that. SQL came back up. That's cool. Also kind of awkward. Never touch iptables? You touch pfSense and everything goes red too. Yeah, so unless anyone has any questions or anything else, thanks for coming. You can continue to try to hack each other and try to make firewall rules so that you can't hack each other. So yeah, thanks for coming. Remember to sign up for things at the beginning.